only just sort of scratched the surface of integration by substitution. So what I thought would be useful is for me to do some 4 more examples with you and see if we can kind of get a bit more comfortable with them. So the first one I thought we'd do is this one here, doing the integral of 1 over 25 plus 4x squared dx. And we're going to use this substitution. They've told us that x is equal to 5 halves tan theta. Okay, who's got an idea of what we can do first? Could we substitute this somehow? Yeah, so we could say, well, x squared must be 25 over 4 tan squared theta. Are we okay with that? That makes sense, doesn't it? Okay. But we also need to, if we're putting everything in terms of theta, we could say, therefore 4x squared equals 25 tan squared theta. Are you okay with that step? We've just replaced this with this. Okay. But we've got to get rid of this dx. So any ideas what we're going to do there? We need a d theta if we're going to put everything in terms of theta. Griffin?
You could do dx d theta.
Okay, yeah, so dx d theta equals, now what happens when we differentiate tan theta? It's 6 squared theta, okay? Okay. So, let's see what this looks like when we start chucking some things in. I've got 1 here. On the bottom I've got 25 plus 25 tan squared theta. And I'm multiplying that, one more thing I should have done here, times both sides by d theta. Yeah? So that's what dx is this. Okay, now I can replace the dx there. Sorry about that. Okay, this doesn't look too helpful at this stage, although is there something we could potentially do here? Yes?
You convert the tan squared theta into 6 squared theta minus 1.
Yeah. Or we know that 1 plus tan squared theta equals 6 squared theta, yeah? Essentially that's what you're saying, right? But we could perhaps change this. We could say that this is 25 into 1 plus tan squared theta. So my next line could read like this. So Griffin knew his identities, and he's like, "Ooh, this looks like I could use the identity to change this into sec squared theta." I've just done the same thing, but I've factorised this first because I'm going to have 25 sec squared theta, because 1 plus tan squared theta is sec squared theta, and this is going to be helpful because that is going to cancel out that. Okay, so our next line will be 1 over 25 sec squared theta, and we can perhaps multiply this out. We'll have 5 on top, won't we? And then 2 times 25 is 50, so that'll be 50 there. But hang on, 5 over 50 is the same as 1 over 10, and then sec squared theta will be on the top, d theta, but then sec squared theta over sec squared theta just becomes 1. So we're really doing the integral of 1/10 d theta. Equals 1/10 theta plus c. Are you okay with that derivation? Is that making sense? So when we integrate this, we go up to the theta to the power of 1. Okay, not quite finished. There's one final step. We want to get it back in terms of x. Okay? So we might go back to this equation here and rearrange it so that theta is the subject. So my first move would be to multiply both sides by 2/5. That will cancel out that and give me tan theta. To get theta by itself, I will say theta is the inverse tan of 2/5 x. And I can now substitute that into here. So that will be equal to 1/10 inverse tan of 2/5 x plus c. Okay, so hopefully we can see as we just start looking at this here, we could do this bit here, couldn't we? By saying that is u to the power of 1/2. U, square root, so u to the power of 1/2. Okay, now we've got to get this and this. So, any potential suggestions as to how we can start figuring out this bit here? Or maybe this bit here. Often it's a good idea to do this. Du dx. What will that give me, Rebecca?
2 plus 2x.
Does that look in any way similar to this? Yeah, this is multiplied by 2 to get this, or 1/2 times this to get that. Okay. Alright. So we kind of want to get it, maybe we can use this to get a dx and that at the same time. So maybe if we go du dx times dx. Just thinking about this. Equals, let's do that, equals 2 plus 2x dx. We're getting close. I hope you can see that. On this side we've got du. We need du. What can we do here? What could we do to this? Because if you look at this right now, this is very similar to this, which we're trying to get replaced. What could I do to this to make it equal to this? Griffin, you got an idea? No? Times it by 1/2. Okay, so if I times this whole thing by 1/2, I'm going to also times this whole thing by 1/2. Now, let's expand that bracket just to make this explicit. I've done the same thing to both sides, so that's going to cancel out. I've got 1/2 du equals, what's 1/2 times 2? 1, 1/2 times 2x, x dx. Now, I hope you can see that this is that, and I can replace it with that. Okay? And now, oh, what do we need to do next before we do anything else? You were talking about it before.
The new
Limits.
limits.
Yeah, that's exactly right. So we're going to pop these values in. X equals 0. That's not x equals 0. X equals 0. U equals 0. X equals 1. U equals 2 times 1. 2 plus 1 squared. 1. 2 plus 1 is 3. So those are our new limits. Now, we're ready to go. This is what it's going to look like. 0 to 3. 1/2, and I'm going to go u to the power of 1/2 du. Let's see if we've replaced this correctly. I've got my limits changed, so that's good. I've got the 1 plus x dx changed to this, 1/2 du. You've got that there. And I've replaced this with u to the power of 1/2, given this here. So I'm good to go. Alright, now we need to integrate. So, we could probably use our brackets at this point. Okay, we raise the power, so it's going to become u to the power of 3 over 2. What does this become? We've got to anyone? 1/3. So let's check that. If we times this by 3 over 2, what do we get? We get 3 over 6. Is that 1/2? Yes. Okay. So this is our final step, is to chuck these values in. 1/3, or another way of saying 1/3 is 3 to the minus 1, yes, times, what's this? 3 to the power of 3/2, that's the first bracket, minus, and the second bracket is going to be 0, 1/3 times 0. Okay. Okay. Now we could do this as a decimal, but we know our index laws, don't we? 3 to the minus 1 times the 3 to the power of 1/2. When we're multiplying indices with the same base, we add the powers. So this will simply be 3 to the power of 1/2, which is square root 3.